Alright, we're on section 10.6, volume of rectangular prisms. And it says, well, first of all, I'm going to let you go ahead and hit pause and copy down this information first. So go ahead and do that. Alright, it says rectangular prisms. It is a three-dimensional figure with two parallel bases that are congruent rectangles. Okay, that is dealing with, again, three-dimensional figure with two parallel bases. So parallel bases meaning the bottom and the top, that they are parallel, and that creates a three-dimensional figure, and they're congruent. Volume says the area of space inside a three-dimensional figure. Volume is measured in cubic units. Okay, length times width times the height, that is your formula for finding volume. So it's a very simple formula. It's very easy to calculate as well, finding the length, finding the width, and then how tall the actual figure is. We're dealing with the height. So let's use that formula. Before we do that, we're going to talk about how to draw a rectangular prism. And drawing it, probably the best way is to create one of the faces. Okay, and the best face would probably be the front or the side. You can use either one. I'm going to start out with a side, and you're going to create that side. Okay, whatever it might happen to be. In this case, it's basically a square. And then so you create your two-dimensional figure. Now you're going to take your sides and you're going to draw angled, and they have to be the same length and parallel to each other. Okay, they are the same length from that point to that point and from this point to this point, and then draw this line over to it, because this line has to be parallel to the front of this line. Okay, we're creating parallel lines. Okay, and these opposite angles would also be congruent as well. Okay, then you bring down this line because it's going to be parallel to this side, and then we're going to connect those, and that's going to be parallel to this, and you start to see the shape as it comes together. Okay, now to make it more 3D, you can make you're basically making this square in the back part of this. So we're going to have to bring down with dotted lines that line, and then with dotted lines for the bottom of this one to match up. So you can see the two squares that resemble each other. And then you're just simply taking basically this line, and you're going to, again, it's hidden, so that's why we're making them dotted or dashed, hyphenated to that point. Okay, and you can start to now see the three-dimensional figure. These solid lines are the lines that you see. The dotted are what are hidden, what's behind that box. This is basically like a tissue box. So that is the way you can do that. Now you could have also drawn this right side face, which is more rectangular, and then you could make a shorter line here, shorter line there, and connect them. And then you're going to bring down this line because it's the same length, and then this line has to be parallel to this line, and they connect, so then you can start to see your shape. This would be dotted, bring that over here, and then this line, it's almost hidden right on top of the other one, or below it, so it makes it a little more difficult to see. But you can see how you can change and turn that shape. It's the same one, just that we're working with this face instead of this face. Okay? And we'll talk and discuss more of this. This isn't something that you're going to actually have to draw for an assignment, but it helps when you are trying to copy some of these down. Okay, and it just takes a little bit of practice, and we'll continue that tomorrow. Now it's finding the volume. Okay, and again, write down the formula first: length times width times height, and you'll simply plug those numbers in. So go ahead and do that and hit pause. All right, what you should have done is take 25 centimeters times the width, which would be this line, and since this line up here is the same line as this bottom one, it would be 12 times the height. And again, according to our associative property, it does not matter what order we multiply these in. You can just simply multiply them, but it is nice to be able to match up the length and the width and the height just so that you are familiarizing yourself with and identifying the correct lines. So 25 times 12 times another 12, which gives me 3,600, and it is centimeters is the unit of measurement, but again, as we talked on the first page, it says cubic, so it is with a 3. And again, that 3 comes from the fact that it is three-dimensional. Okay, that is dealing with that's the relationship, and when we did square, it was two-dimensional figures. Okay, volume is the only one that is cubed. Area is the only problem that you will be squaring, and then your circumference and perimeter, those two are just plain units of measurement because it is measuring a simple distance. Okay, so take a look at your answer. If it matched up, great, then obviously you understand it very well. If not, we'll try it again here on this next problem, and again, you're just multiplying those three numbers together, and you can certainly hold that question and ask it tomorrow. Find the volume, so go ahead and hit pause and then solve. All right, again, length times width times height, and you're going to find the length, and length is usually going to be your longest measurement, times width, 9.3, times the height, how tall it is, 4 2/10. Simply take your calculator, 12.6 times 9 3/10 times 4 2/10. And I plugged it wrong on my calculator, so bear with me. 12 6/10 times 9 3/10 times 4 2/10. There we go. And we get 492 156 thousandths. Now, it does say round to the nearest hundredths. It will tell you that on homework. Actually, tenths, my apologies. It tells you to round to the nearest tenths. So my tenths is the 1. So it's going to be 492, and the 5 is going to make that number go up to a 2, and it is meters cubed. That's your answer. If you have any other further questions, again, please ask. If not, we'll be working on this tomorrow, and have a great evening.